Hello everyone, welcome to Data Science Community. In today's lecture, we are going to discuss about how we can choose perfect machine learning algorithm for our problem statements or for our machine learning project. Okay, and it is also very important question for interview point of view. Okay, so for that, let's start our discussion. How do you choose a machine learning algorithm? Okay, it is very important question. Okay, so I can help you with that, how you can answer this question. Many times this question asked in interviews too. Okay, so first you need to understand if we are talking about any use case, for example any use case which means our label data. Okay, so for label data the first name comes as supervised learning. Okay, it is a type of machine learning algorithm. It is a type of machine learning in which we use label data to train our model. Okay, I make separate video on regression classification. In that video I already explained about supervised learning. Okay, and in supervised learning you can see here we have two types of supervised learning, which is regression and classification. Okay, so we use, for understanding regression and classification, you need to understand the types of data, because here you can see that regression works for continuous data and classification works for discrete data. Okay, so what is continuous data and what is discrete data? Okay, so the continuous data is any numerical values. Okay, if our data set wants to if our problem statement is like you need to predict the salary. Okay, the tip data set, house price data set, predict the, for example, predict the car price. These kind of data sets are come under continuous data, because in this data set the output is a continuous value. For example, the price. Okay, house price, every house is having different price. Okay, and the price comes in a numerical value. So we did not put this kind of data in categorical or discrete data. So these were the continuous data. Okay, and the discrete data is when we are talking about emails classification, spam not spam. Okay, for if we are talking about male female, if the person survived or not. Okay, these kinds of data is come under discrete data. Okay, so we are performing classification algorithms, or we are using classification algorithm for such kind of data. I already make separate video on regression and classification. You can go and check it out. That video, the link is in a description. Okay, so let's see what all algorithms we have. Okay, so here we have linear regression for continuous data. Okay, the most popular algorithm for continuous data is linear regression. Okay, and for discrete data we have different classification algorithm, which is logistic regression, decision tree, random forest, XGBoost, KNN, and so on. For example, SVM, and there are so many algorithms which we have in classification. Okay, so in this video we are particularly talking about these kinds of algorithms. Okay, when we are talking about classification algorithm, the decision tree, random forest, and XGBoost were the most popular. Okay, so let's see, still our question is there, which algorithm and when should we use that algorithm. Okay, so for that let's go with our Jupyter notebook. Okay, that here I am using pair plot. Okay, so the answer of the question how you can choose the best algorithm for your machine learning projects, okay, or your machine learning problem statements. So the answer is by using pair plot. Okay, so here I am using pair plot and let you know how you can choose your machine learning algorithm by observing the pair plot. Okay, so for making pair plot of your data set, you can use this library named as Seaborn, okay, and matplotlib. Okay, so these two libraries you need. One is matplotlib.pyplot and another is Seaborn, and here I am using pandas to load my data set. So here I am using advertising.csv and making the pair plot. Here you need to provide the name of your data set, and here you need to provide the name of column on the basis of which you want to plot this graph. Okay, so basically in this, here you need to mention your target variable, okay, and for what you need your output. Okay, so for this you need to mention the column here, and on the basis of the categories present in this column, the graph is built. Okay, so now you can see, I can open this photograph in another tab so that it will be visible you properly. Okay, so here, as you can see here, and let me know how or what you observed in this chart. Okay, please comment down below and let me know what did you observed in this chart. Okay, I will give you a big hint to choose the algorithm. Okay, and the hint is, you can see here this line, okay, is at 0 and this lines were at 1. Okay, so here you can see that either our output is 0 or our output is 1. Okay, so you can also see here 0 and 1. Okay, or you can see here our data point were in a proper line and in either on 0 or on 1. Okay, there is no points between 0 and 1. Okay, or neither a point is having value greater than 1 or less than 0. Okay, you can observe one thing. So this was the hint for you to guess the algorithm. Okay, you can pause the video and write the answer of this question, that which algorithm should we use for these kind of pair plot. Write the answer on the comment section. Okay, the answer is logistic regression. Okay, because I already make one video on logistic regression. Logistic regression either provide the output as 0 or 1. Okay, the output of logistic regression is either 0 or 1. So and these kind of problem statements are called linear classification. Okay, so for linear classification we can use logistic regression. In this photograph, okay, so this was the one more pair plot. Okay, so I'll zoom out the video, image, so that it was clearly visible to all of you. Okay, so this is the another pair plot. So you can see that here, okay, here you can see that neither your value in the form of 0 or 1. Okay, so for logistic regression, just to tell you, okay, for logistic regression our values should be in a form of 0 or 1. Okay, so our graph for logistic regression is somehow look like this. I need to change the color. Okay, so either a point like this, the point is on 1 only. Okay, and either a point is on the 0. Okay, for logistic regression our graph looks something like this. Okay, so either for logistic regression, either the value is 1 or the values are 0. Okay, or if you are aware about KNN, or if you know something about KNN, it is clear to everyone that for KNN your values should be grouped. Okay, either on the basis of colors, okay, on the basis of shape. Okay, so there are different parameters your values present in a form of groups. Okay, the data points is present enclosed with each other. Okay, or your data were very overlapped. In such kind of condition, I can show you one graph for KNN also, but now you can just understand what I'm saying, that in this pair plot, which is the image is present on the screen, that for this kind of charts where the data points are not in a form of 0 or 1. Okay, you can see here the values present like this, but it is not in a form of 0 or 1, because the value is either 0 or you can see the value is present on 1000, not at 1. Okay, so don't confuse. Okay, so you can see that the values are not in a form of 0 or 1, or not in a form of not in a form of groups. Okay, so here you cannot use logistic regression, or you cannot use the KNN. Okay, so the remaining algorithms which is other remaining algorithms which is decision tree, random forest and XGBoost. So these kind of algorithms are suitable for these kind of plots where the values were not in a form of group or not in a form of 0 or 1. So in these kind of values where the values are overlapped but not that much. Okay, when you have very so if you are having the graph in which the data points were much overlapped, so these kind of for these kind of charts you can use KNN. And if your data points is overlapped but not that much, okay, as you seen in these graphs, so for these kind of graphs you can use decision tree, random forest and XGBoost. Many people use random forest and XGBoost instead of decision tree because decision tree provides overfitting, and random forest and XGBoost will use many decision tree in their algorithm. Okay, so I can show you one more pair plot. Here I am using iris.csv. I already make one video on iris.csv data analysis project. The link is in description, you can go and check it out, that video also. Okay, so here I am using iris data set, and let's go directly on the pair plot of this graph. Okay, so this was the pair plot of this graph. I can open for you in a new tab. Okay, so this was the complete pair plot. Here we have different classes of iris. Okay, so these were the different class of iris, and here we have petal length, petal width, sepal length, sepal width. Okay, and here you can see that the data points are grouped. Okay, you can see here we have our three classes, and then our data points is present in our group of these three types of flowers. Okay, so in these kind of plots you can use KNN, which is K nearest neighbor, which is a one more classification algorithm that you use. Okay, so for these kind of plot you can use KNN. Okay, and here I can show you. So here I can show you I implement logistic regression and KNN both in this data, and if we are correct that this data is for KNN, then our accuracy in KNN is more than the logistic regression. Okay, so first let's we have this Y. Okay, here we have our all classes. In X we can store our independent features, and Y we can store our dependent feature, which is our output, and here we have all the inputs. Okay, and here I am importing the libraries, which is sklearn. Okay, dot model selection import train test to split. This is for splitting my training and test data. Here I imported the logistic regression model, and here I am importing my KNN classifier. Okay, and here I have my matrix. For by using this I can find my accuracy, and here I have pre-processing to change my string values into numerical values, because every machine learning algorithm will work on numerical data. Okay, so I need to convert my data in string into numerical. So these class I need to convert this class into a numerical form. So here I am using label encoder, preprocessed label encoder. Okay, now here I use fit transform function to encode these strings to numerical values. Okay, I can okay, so now here I am splitting my data. Okay, and here we have xtrain, xtest, ytrain, ytest. Okay, here I imported my KNN model, and here I fit my model, and by using this fit function you can train your model. Okay, and by using this dot predict model dot predict function you can predict the value for the test data. Okay, and by using this matrix dot accuracy score, here we provide a predicted value and already present test values. Okay, which is already present. Okay, so here you can see that 97% accuracy. We get 97% accuracy by using KNN. Okay, and let's see for logistic regression. Here I imported my logistic regression model, and here I'm using fit method to train my model, and here I predicted my value for x test, and here I'm checking the accuracy score for x test, and here I'm getting the accuracy score as 95%. So here you can see that KNN is more accurate than logistic regression. Okay, so I hope this is clear to everyone. If you have these kind of data where the data points are divided into groups, then you can use KNN. Okay, because KNN classify the data point on the basis of Euclidean distance. Okay, Euclidean distance means the distance. Okay, so it will find the distance between these points and these points, the minimum distance from this point, okay, this point. So it will find the distance between here to this point, here to here, and here to here, okay, which is having the minimum distance. This data point will come into that category. Okay, so find the distance between the test point and the already available points. This distance is known as Euclidean distance. So KNN use Euclidean distance for finding the for predicting the value. Okay, and in these kind of data where the value is present in a form of 0 and 1, so for these kind of data set we can use logistic regression. And for the data points which is not present in a group or not having the value 0 or 1, so for these kind of data we can use decision tree, random forest, and XGBoost. Okay, another method for finding perfect algorithm is by applying all the algorithm and finding their performance metrics. Okay, and after finding the performance metrics, you can see your accuracy score as we checked here. Okay, so here we use matrix dot accuracy score. So you can find the accuracy score of each and every algorithm and apply that algorithm which is having high accuracy. Okay, there's two ways to find which algorithm is perfect. First is by using PRplot, and second is by using performance metrics. And if you want a separate video on performance metrics for classification algorithms, which is also known as confusion metrics, then comment down below. I will make separate video on that also. Okay, I hope you will enjoy this session. So thanks for watching. Like, share and subscribe for more such videos.